So, 8051 microcontroller, we have discussed about the structure of the 8051 microcontroller. Okay, so today I'll start with the 8051 and pin configuration of the 8051 microcontroller. Okay, so pin configuration, it is difficult to remember the pin configuration for any kind of the microcontroller circuit or any kind of the microprocessor circuit, right? So I'll try to explain like this so you can easily remember what is the pin configuration of the 8051 microcontroller, right? So here you can see, so in 8051 microcontroller there are the total 40 pins. Okay, there are total 40 pins in 8051 microcontroller. Okay, so if you remember the architecture of the 8051 microcontroller, it has 4 input output and parallel IO ports. Okay, 8-bit parallel IO ports, right? So 4 inputs. So each port contains total 8 bit. So 4 parallel ports are there. Okay, so normally you can represent the numbering of the pin is like this way. Here it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then 21 starts from here. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, and 40. Okay, in digital electronics also you have seen lots of IC diagram. So in every IC you will have the ground connection as well as the VCC connection. Okay, so in this 8051 microcontroller, so ground connection will be, that is pin number 20 is like ground connection and pin number 40 is the VCC connection. So before writing other components, you can directly write as the pin number 20 is ground and pin number 40 is the VCC. Now come to the other ports. Okay, so there are the total 4 ports. First 0 will be here, 0, 1, 2, 3, like this way I will represent the ports. Okay, so each port has total 8 bits. Okay, total 8 pins are associated with the one port. Okay, so here first 0, 1, 2, 8. Okay, so here it is P02, P7, P00, P07. This is the port 0. Port 0, there are total 8 bits. The port P00 to P07. Okay, pin number 1 to pin number 8 are associated with the port 0, 0 and the port 00 to port 07. Sorry, it is 10. Port 10 to port 17. Okay, so here it is port 1, then port 0 like this way, and port 0, 1, 2, 3 like this way you have to represent. Okay, so I am not writing each and every port. So port 1.0 to port 1.7 here, 1 to 8. Okay, next come to the port 0. Port 0 will be 1, 2, 3, 4, 5, 6, 7, 8. These 8 pins are associated with the port 0. So port 0, 0 to port 0, 7. Okay. So these pins are associated with the A D0 to A D7. What it is? I will tell later. Okay. Now here, so pin number 9. This is reset pin. RST. After representing port 1 from this side, you have to, whichever port is remaining, that will be the reset pin. Okay, now come to the 10 to 17, these 8 ports. Okay, 10 to 17, total 8 ports. These 8 ports are associated with the 0, 1, 2, 3. Here it will come port 3. Port 3, 0 to port 3, 7. Okay, this 10 to, so port 1, then reset pin, then port 302, port 37. Okay, here also I will tell something. Okay, I am just first representing each and every ports. Port 0, port 1 to 8, 1 port. Here 39 to 32, port 0. Again, you can left reset pin. Okay, and after that 8 ports are associated with the port 3. Here also you can see if you go down to here. Okay, so this is port 2. Okay, so port 2, port 202, port 27. Okay, if you go count from down to port 20, pin number 21 to 28, these 8 ports are associated, pins are associated with the port 2. These are like A8, A0. Okay, so port 0, port 1, port 3, you are numbering like this 1, 2, 3, 4 like this. So here also 0, 1, 2, 3, 4 like this way. Here also 0, 1, 2, 3, 4 like this way. But here it will start from 0, port 0 here and port 2.7 here only. Okay, so port 20 and port 27. Okay, now so here port 1 are only all the ports on are connected with the external device. If you want to connect external device, you have to connect with the port 1. Also you can connect with the other port, but other ports have some other functionality. Okay, so but this port 1 does not have in any other functionality. You can directly connect any kind of the external device with the port 1. Okay, any kind of the external device you can connect with the port 1. Okay, so port 0 to port 1, no other function. No other function. Okay, here no other function. Now reset pin. So normally if you upload some program in a microcontroller, now you need to upload a different program. You need to execute the second program inside the microcontroller. So for that you have to you have to press the reset button. Reset button will be connected with this pin which gives the 0. 0 means entire program will be removed. The current program will be removed and the new program will be installed inside the 8051 microcontroller. Okay, so this way the RST pin is required. Next is the port 3. So port 3 has some other functionalities. Okay, what are the functionalities? Here total 8 pins. Okay, so port 30. Port 30 have the RXD, port 31 have the TXD, then INT 0, then INT 1, timer 0, timer 1, then read and then write. Okay, total 8 pins. 8 pins have 8 different functionalities. Okay, first is the port 30 RxD and TXD. When so you will have the serial communication. Okay, you can transfer the data serially through the 8051 microcontroller. When you transfer the data serially from the 8051 microcontroller, you need to transfer through the pin number 11, which is associated with the TXD. Okay, now if you want to receive the serial communication from other device to 8051 microcontroller, then you need to connect that other device with the pin 302 or pin number 10. Okay, port 3.0 or pin number 10. This is the RxD. Okay, these two are completed. Now INT 0, INT 1. So I have told that there are the total 5 interrupts. Okay, 2 INTs, 2 in INT, 2 timer. Okay, one is the serial communication interrupt. Okay, so INT 0, INT, if you are giving two interrupt signals are there, so if you connect the external device, you have to give the priority for external device, then these two timers are in, and you have to send the signal through these two terminals 12 and 13, and pin number 14 and 15 are associated with the timer. When you need the timer program, so you need to connect the program, you need to connect the function or device with the T0 and the T1. Read and write operation, pin number 16 and the 17. Read and write operation means so when you want to transfer the data, when you want to store the data from microcontroller to other device or external device, you write, this is the write operation. Okay, and when you want to retrieve the data from other device to microcontroller, this is the read operation. Okay, so when you connect the data and if you want to store copy the data from memory to the 8051, so you need to give the read signal. Okay, read signal should be activated, and for write signal should be activated. You can send the signal through read and write terminal. Okay, for activating read operation and the write operation. Okay, next pin number 18 and 19. Okay, these two pin number 18 and 19. So these are associated with the XT1 and XT2 oscillator. Okay, you can give different kind of the frequency you can connect the oscillator. So in 8051 on chip oscillator is also there, but if you need the external oscillator, if you want to connect the external oscillator, okay, so then you need to connect xt1. Two different terminals are there for oscillator. You can use any one or you can use both, okay. So different frequency you can give through the this pin number 18 and the pin number 19, okay. The left portion is completed. Now come to the right portion, okay. So here port 2 are total 8 pins, and 8 pins are associated with the A0 and A0 to A8. A0 to 8 you have to the total 16-bit address bus is there, and total 8-bit data bus is there, okay. So the pin number port 2 and port 0, these two are associated with the address bus. So lower order address bus is associated with the port 2, and the higher order address bus is associated with the port 0, okay. Along with, so in order to reduce the pin configuration, okay, so that in the same port 0 is linked with the data bus, 8-bit data bus. You can see here I have written the 8AD0 and AD7, okay. So you can demultiply. So data bus and address bus both are multiplexed, okay, inside the port 0, okay, due to the reduction of the pin number, okay. And this is the address bus is lower order address bus here, and higher order address bus is associated with the port 2, okay. Now left 3 more pins are there. Some functions are available in these 3 pins, okay. So I am writing here. Okay, so PSEN. Okay, this means program, store, enable. P means program, S means store, EN means enable. Okay, program, store, enable. Okay, when you connect the external memory, okay, here on chip memory is there. I am telling about when you connect the external memory. Okay, when you connect the external memory, and if you want to read code from the external memory, okay, then this program, store, enable should be high, okay. This should be high. So that means this is used to read the program memory from external memory, okay. To read the program memory from external memory. If you have connected the external memory and you have installed some program where you need to retrieve those programs, this signal should be activated, okay. Next is the ALE, okay. So ALE is address latch. A means address, L means latch, E means enable. Address latch enable. Okay. Now you want to connect these pins with the other memory chip, okay. Then this signal should be active low, okay. And this signal should be active low. And now if you want to demultiplex, here you can see address bus and data bus both are multiplexed, okay. If you want to demultiplex address bus from the data bus, you need to send the signal through the address latch enable, okay. You need to send the signal through the address latch enable, right. So why? So if you want to demultiplex, okay, address bus and the data bus, okay, you need only the address bus, okay, 16-bit address bus. So for that you need to demultiplex the address bus from these terminals, okay. So for that you need to active the address latch enable, okay. Next is the E means external access, okay. E means external, A means access, okay. So that means, again I am telling, so if you connect the external memory with the 8051 microcontroller, then the external memory should be active high, okay. But in 8051 microcontroller you have on chip, you're not required to connect the external chip. If you don't connect the external memory with the 8051, so this EA should be always connected with the VCC. So pin number 40 and pin number 31, this should be shorted, okay. So that means a address latch external access, okay. So if you connect the external memory here, so you need to active the external access signal, okay. So address latch enable demultiplex the address bus and data bus. Program store enable means if you want to store program from external memory, okay, to 8051 microcontroller, then program store enable is required to activate, okay. So this is about the 8051 microcontroller pin configuration. Again I am summarizing this thing. So there are the total 40 pins, okay. So first the 1 to 7 pins are associated with the pin number port number 1, okay. All ports are 8 pins, and then pin 9 is the reset. and pin number 10 to 17 are associated with the port 3, which has some other functionalities, like serial communication, interrupt, timer, and the read write operation. Okay, now the last three, and among these three, 18 and 19 are associated with the oscillator, and 20 is always ground, 40 is VCC, and below 40 there are the total 8 pins. These 8 pins are associated with the port 0, and if we see from 21 to 20, these are associated with the port 2. Port 2 is only the address bus, but port 0 has address bus as well as the data bus. So in between port 0 and in between port 2, you will have the extra 3 pins, right? These 3 pins are associated with the program store enable, address latch enable, and the external enable. Okay, so if we try to remember like this way, it will be very easy for you. Okay, so next class I will start with the different kind of the addressing mode of the 8051 microcontroller. Thank you.